Okay, AFDA students, so this warm-up is going to help us with some of the questions that you need to answer on your Unit 3 project. So the graph that we have here shows the number of police cars on the x-axis and the average speed of the motorists on the y-axis. And you can see when the motorists see more police cars, their speed lowers. So if the police department has 10 cars, what is the practical domain? Remember that domain is your x values. And the reason why we're suggesting that you use set notation is because we can list all of the possible values for the police cars. You could have 0 police cars, you could have 1 police car, all the way up to 10 police cars, but you can't have a fraction of a police car. You're never going to have 3.2 police cars. Okay, so those are all of your choices for x. Your range is your y, and miles per hour, normally you could have any number of miles per hour between 0 and the top speed of the car. It could be a decimal, and so interval notation sometimes is a good way to represent the speed of the car because there are so many possible values. But in this case, because our x's can only be the numbers 0 through 10, our y's can only be the outputs of this function here. Y equals negative 1.8x plus 69. So to find the range numbers, we are going to substitute in all of our x values, and that will give us a list of y values. So for example, y equals negative 1.8 times 0 plus 69. And we have y equals negative 1.8 times 1 plus 69. And we'll do that all the way up. And I'm not going to write them all out, but I am going to show you on Desmos how I'm going to find all those answers. All right, so I substituted the first one in. I substituted in 0. And my answer was 69, so I'm adding that to my range. And then I'll just change the 0 to 1. And I get 67.2. And I'm going to keep doing this to get all of the numbers. 65.4. 63.6. And so I'm writing all of these numbers on my paper. Down here. All right, so I will continue doing this all the way up until x equals 10, and I will get the corresponding y values, and then we'll move on. Okay, so this is the list of numbers you should get. If there are 10 police cars on the highway, what would be the average speed of the cars? So remember that police cars is an x value. So I'm going to take my equation, and I'm going to replace the x with 10. Okay, and you can multiply negative 1.8 times 10, and you can add 69 to that, and we actually already did that when we were calculating our range. So I got 51 miles per hour is the speed if there are 10 police cars. The next one says, how many police cars are there if the average speed is 60 miles per hour? And average speed is on the y-axis. So this is going to be a y value. All right, so this time when we take the equation, we're going to substitute 60 for the y. Oops, and I forgot my x. The x goes right there. Then subtract 69 from both sides. I have negative 9 equals negative 1.8x, and divide by negative 1.8. And we get x equals 5 police cars. All right, and that actually matches what we did before, because when we had 60 miles per hour, that was what we got from 5 police cars. Okay, these questions do definitely show up in your project. What is the slope and what does it represent? What is the y-intercept and what does it represent? So we're going to try to figure this out in the context of our problem, and then I want you to take that knowledge and use it in your project. So your slope, you know, is the change in your y, your rise, over the change in your x. That's your run, rise over run. And our slope, in this case, is negative 1.8. So negative 1.8 is my rise over run. Now, negative 1.8 isn't a fraction, so to make it a fraction, I will divide it by 1. And the reason I divide it by 1 is because that number will not change negative 1.8. Negative 1.8 divided by 1 is still negative 1.8. All right, so now negative 1.8 is my rise. That means that my speed is going down 1.8 miles per hour. And so I'm going to write that. The speed decreases by 1.8 mile per hour for every 1, and then on my x-axis it's police cars, so for every 1 police car. All right, the y-intercept, remember, is the b of y equals mx plus b, and so in this case the y-intercept is 69. You can also kind of see that in the graph. It's just a little bit below 70, so that would be 69. And we're using our same equation, y equals negative 1.8x plus 69. And so in this case, the y-intercept is the point here. The y value is 69, and the x value is 0. So that's going to be 0 police cars and a speed of 69 miles per hour. Okay, so if you turn your paper over, there are 2 more questions that are going to help with your last analysis section of your project. So in this unit, we talked about linear data, but data does not always have to be linear. There are a lot of different functions that could model it. 2 of those functions are quadratic and exponential. An exponential can either rise or fall quickly in one direction. So this one is decreasing. It could also be like this, increasing really fast. This one says what type of relationship is shown in the graph and how do you know? So comparing it to the graphs, because it goes down and then up again, it looks quadratic. And you should explain why in your own words. You might just say that the data goes down and then up again, and that describes it in your own words. Or if you are familiar with the word parabola, that is the shape of a quadratic equation. So you could say this is quadratic because it forms a parabola. Okay, and then if I compare the last one to the graphs above, it seems to be only increasing and there's no curve to it, so it looks linear. And it can be as simple as explaining it's linear because it forms a straight line.